Okay. Writing a repeating decimal as a fraction. We can use the concept of geometric series to do this. It's not something that's obvious, but I'll show you once, and then we'll just talk about what the shortcut is. Okay? What I can do is if you write this as 4, 2 repeating over and over and over again, if we break that down, if you think back to this problem from the beginning of the lesson, let me find it, here it is. If you think back to this lesson, what did we have? We had a repeating decimal. How did I get that? By adding decimals like this, where I just kept pushing that 2 to the back end of the decimal. So when I write my repeating decimal in this case, I can write that as the sum of 0.42 plus 0.0042. That's where I get this from. I can write that as plus 0.000042. That's this one. If you think about how we could add all those together, and what we get is a geometric series. How am I getting these consecutive terms? Let's look at it. What is this? This is the first term in the series. What is the common ratio? It's 0.0042 divided by 0.42. And if you calculate that, you get 0.01. So my common ratio is 0.01. The first term in this sum that I wrote is 0.42. So as a geometric series, as a rule, I can write that like this. 0.42 times 0.01 to the n minus 1 power. The way I write this as a fraction is, if you remember, an infinite sum for a geometric series can be calculated by taking the first term and dividing by 1 minus r. So I'm writing the sum as a fraction using this formula. That's how the decimal becomes a fraction. A sub 1 was 0.42. The common ratio was 0.01. So from this I get 0.42 over 0.99. And that looks silly because I have decimals in the fraction. So if I multiply the top and bottom by 100, which is just 1, I get 42 over 99. There's my fraction. So, to summarize, if I can express a repeating decimal as a geometric sum, I can use this formula to write it as a fraction.